Hello, IB Bio students. So today we're going to continue looking at 9.1 and we are going to focus on water conservation. The application is adaptations of plants in deserts and in saline soils for water conservation. So you need to be able to list and explain the different adaptations of different plants. So plants that are found in desert environments or environments where perhaps they can't have enough water are called xerophytes, and plants that are found in saline soils, these are called the halophytes. So xerophytes are known as desert plants, but they're not only desert plants. So when we think of a xerophyte, and we think of a desert plant, we think of a cactus, of course. Oops, cactus. But keep in mind that there are other examples of xerophytes. For example, pineapple is also a xerophyte because they live in high altitudes, and it's hard for them to find water, or they might live in areas where there are droughts. For example, bromeliads are also xerophytes because they live in tropical forests, but within these tropical forests there might be some dry periods, so it's hard for them to find water. And then if you are chaparral plants, chaparral is a type of ecosystem or biome. So for example, parts of Southern California where it's really dry, or Mediterranean plants where it's really dry, these are also xerophytes. And then plants that are found in Arctic-like conditions, like resurrection plants, they also find it hard to find water. So all of these are examples of xerophytes. So if you're having trouble finding water, then you are called a succulent. And succulents have these adaptations where they can store water in their stems and their modified leaves, for example. Okay, so let's look at the xerophytes first. And let's move here. So these are here. Let's start with the list here. So xerophytes, and again, don't think only of cactus, right? Think of things like pineapple, for example. So xerophytes can have reduced leaves. So if you reduce the total number and size of leaves, this will reduce the surface area available for water loss. So that's one way of conserving water. If you do think of a cactus, then think of a cactus with, for example, I'm horrible here at drawing, but these modified stem are present in the form of leaves, instead of leaves, sorry. So a cactus, they don't have leaves, but they have these modified stems where water can be stored, and then they have spines instead of leaves as well. So sometimes these xerophytes, they have these rolled up leaves, and rolled up leaves reduces the exposure of the stomata to the air and hence reduces the evaporative loss. So let me quickly show you this picture here, because I think they do a good job here at showing you the rolled up leaves. Here you see something known as a marram grass, which is a beach grass. And notice how if the leaf here, it's rolled up like this. So the rolled up leaf protects the boundary layer from wind and reduces the outward surface. And then you have these tiny little hairs here that surround the stomata. So having that additional layer here of hair is going to stop the water from evaporating. Okay. Another thing here to think about when you're looking at a cactus, they have these waxy cuticles, and that's going to reduce evaporation. They also have these stomata in pits with hairs, and they obviously don't have leaves, but they have these spines, and the spines or the spikes prevent water loss to herbivores. All right, so let me move back here. So, like we said previously, we have also modifications or adaptations like a thick waxy cuticle, right, to prevent water loss from the leaf surface. Stomata in pits, so we talked about that, and these stomata with pits are surrounded by hair, and these hair trap water vapor and reduces transpiration. They have low growth, so they're low-growing plants, so they're less exposed to the wind and more likely to be shaded, reducing water loss. And they have this CAM physiology. CAM stands for crushylation acid metabolism. And within this metabolic process, these types of plants, they're going to open their stomata at night, reducing water loss via evaporation. So that's what it means to be a CAM plant. You open your stomata at night. The carbon dioxide is taken in, and then that carbon dioxide gets stored, and then the plant can use that carbon dioxide for photosynthesis at night or during the day. Just keep in mind that during the day the stomata remains closed. Photosynthesis can still happen during the day with the carbon dioxide that it's stored during the nighttime. Okay. And the halophytes, these are plants that can tolerate salty conditions such as marshlands. And they have something known as cellular sequestration, and that means that they can sequester the toxins or toxic ions and salts within the cell wall or the vacuole so it doesn't reach other parts of the plant. They have something known as tissue partitioning, and that means that plants may concentrate salts in particular leaves, and then those leaves will fall. That's called abscission. And then they have root level exclusion. That means that the roots are picky about what they take in, and they can sometimes exclude approximately 95% of the salt that's found in the soil. And the salt that does manage to come in, certain parts of the plant like stems, they contain these salt glands which can eliminate the salt. And they have an altered flowering schedule. That means that the plant will flower at specific times, usually during the rainy season, and that's going to help dilute the amount of salt in the environment and is going to minimize the salt exposure to the plant. So here you see the adaptations, where they occur, right? If they occur within the roots, within certain glands, within the leaves, within the cell itself, inside the vacuole. All right, and that's pretty much it for this.